All right. Volume. Okay. Since apparently we didn't really give much attention to the homework assignment last.
It's okay.
Just a quick reminder.
Okay. I'm gonna write that down right now.
2 plus 2 is 4. No, it's 5.
We're on screen class, people.
Last class we did area between two curves. So like, for example, if we had some function f of x, and then here was g of x, if we wanted to find the area between those two curves, let's say this is from, we would do the integral from a to b, and we would do f of x minus g of x dx. So we always take the upper curve minus the lower curve, and then if it's in terms of y, we do right minus left. Okay. I just wanted to review that because the volume depends on that. Okay, so what we're going to do is we're going to take a volume of a solid. There's two ways that we can do this. One, we're just going to look at cross sections, and then we'll look at what happens when we rotate. This can be a difficult lesson, so I really need you to make sure you're focused and attentive. So the volume of a solid is basically the integral of the area. Kind of neat, actually, that if you have the area of a graph, it's kind of like take for example, like a cylinder, for example. Let's say we had a cylinder and you took the base. What shape is the base? It's a circle. So if you integrated, in other words, if you took infinitely many of these circles over whatever the height would be, you would end up with the volume of that cylinder. So picture like infinitely many circles, you're integrating that area of that circle over whatever the height would be.
Oh, the cylinder.
Of a cylinder. Like if you, right? Yeah, just picture your circles, right? If you had infinitely many of those. So if I wanted to figure out the volume, of this, I would do the integral of pi r squared. And you get the volume.
Really?
It's actually, yeah. So there are two different methods. This is the first one, the method of slicing. These are using what we call cross sections. No. Okay, method of slicing. It's kind of like, let's say it was the cylinder example that I drew on the board. If I were to slice right through this, what shape would you have? We already said it. It's a circle. Okay, so you have a two-dimensional shape. If you took that area, so in this case it was pi r squared, and you did the integral, that would give you the volume of the cylinder, the three-dimensional shape. So you integrate. Yeah. So we're going to have limits of integration. Let me give you a different example here. Let's look at this first one. It's a little difficult to see because I copied this from the book. They made basically something two-dimensional and tried to show it three-dimensionally. Take the graph. This is y equals square root of x. And this is y equals negative square root of x. We want to look at, it says here, from 0 to 4. So here's 1, 2, 3, 4. So, what we usually want to look at first is what is the cross section length? What's that equal to? So in other words, if I want to measure from here to here, what's that length? Okay, so it's gonna be right here, but what is it gonna be at any other point?
Like from,
Okay, what's the distance from here to here at any point on that curve? It's square root of x.
oh,
What's the distance from here to here? Square root of x. So what's the distance from here to here? It's 2 square root x. Guys, cross-section length has to be in terms of x. It can't be like an actual number. It can't be 8 or 6 or anything like that. It's just, if I were to measure the distance, it's going to be whatever the square root of x is here. I mean, that's what the curve is representing. And the distance from here to here is square root of x. So all the way across is 2 root x. Now, we want to read what type of cross sections we have. They're always different shapes, so we want to just read very carefully in the directions. These are going to be squares with bases in the xy plane. So that means so what's the area of a cross section? Which in this case is a square. Okay, so the cross-section length is 2 root x. What does this represent? So can you kind of, not even look over at this one. Do you see how here, this is the cross-section length, and imagine that there are infinitely many squares coming out of the board at you. So like, this would be the length of one of the bases of the square, and then it comes out, makes the squares out of the board, to make a 3-dimensional shape there. Can you kind of imagine? So what would be the area of that cross section? How do you find the area of a triangle, or of a square, excuse me?
the side squared.
Okay, so this is the side length. So it would be 2 root x squared. So simplify that, what do we get for the area?
4x.
We get 4x. So it's like a process. Basically what you want to do is first see what the cross-section length is. And then in terms of the example, what does that represent? This is the side of a square. What do we want to find? We want to find the area of the square. Which is 4x. Now what? We want to find the volume. Okay, so remember that, yeah, it goes from 0 to 4 of 4x dx. Now, in this chapter, for the quiz, all I'm gonna ask you for the setup, and then you can do the answer on your calculator. This one's pretty basic, so you could just do 4x squared over 2, and then evaluate it. But right, so we get 2x squared, evaluated from 0 to 4. What do we get?
3.
Okay, take a look at the next one.
Exactly. I'm actually okay.
Why are you making things up?
Thank you for that. Okay, in case anyone was unclear. Andrew does have a clue. Okay.
Has that been like in your head for the past 20 minutes of this meeting? No, it came up when I answered this one very fast, and then I was like, wow, it's so fast. Wait, Andrew's faster?
Okay, take the above example, and now our cross sections are semicircles. Now, let me just explain. My cross section length is still 2 root x. That's the diameter. Good. Imagine instead of these being squares, they're semicircles coming out of them.
So it's 1/2
Okay, so if this is the diameter,
root x.
so again, what you want to do is you want to take your cross-section length, and in terms of, if this is a semicircle, figure out what that cross-section length represents. So if you have that, that would be the diameter. Can everyone kind of picture So if that's the diameter, what do we need to find the area of a semicircle? Okay. It's gonna be 1/2 pi r squared, so this means the radius would just be square root of x, right? Half of the diameter. So what's my volume? Well, the integral's still gonna go from 0 to 4, but I want 1/2
Wait, why are we finding the
pi. Oh, well, I guess I could. 1/2 pi times square root of x squared. So here's
Why
the.
can't we simplify it?
Yeah, we can. What is this, what does this end
It's
up being?
x, so you get
1/2 pi x?
pi, you get
So I'm gonna move the 1/2 and the pi out in front. Right, the square root of x squared, the square root and the power are gonna cancel each other out. Notice the 1/2 and the pi, because those are constants, I just think it's always easier just to bring them out in front of the integral sign, because then what do you have? You just have x, so it becomes x squared over 2. No. Okay, and what do we get for that? You can leave pi in the answer, that's fine.
4 pi.
Here's that.
here's the what's going on? No way.
You guys get so caught up in my jokes that you realize that I'm okay.
No, we know you're okay.
I think that's part of the reason we laugh at you, because somehow you still manage to understand it.
Okay.
That was on.
Okay, so next one. Okay, this is the second method. The first one was slicing. Next one are circular cross sections. So it looks like a goldfish. Now. Okay, this is still kind of like slicing, where it's the area formula, but basically it's a circle. Take an area, and if you start rotating it, you get a 3-dimensional solid. Okay, that's why these are called solids of revolution. So volume,
It's a two-dimensional, if you're listening to
yeah, so if you take any kind of curve,
if it was like this paper and it was going like this, so it was
right.
a cylinder.
Exactly. So if you just took a horizontal line and you bounded it and looked at the area under the curve and you started rotating, you have a cylinder. So you could actually, you could prove all your volume formulas using calculus, using this volume of solid of revolution. It actually all comes together. You would actually be able to prove that the volume of a cylinder, which is pi r squared times h, would give you the same result as just taking a horizontal line and doing the integral of that. It's kind of neat. So basically the volume here okay, so our radius is just equal to the function, whatever the function that's being bounded. So here we have an example. This is a calculator problem, by the way. Here's the curve y equals 2 plus x cosine x. So if we bound it from -2 to 2, and we look at this shaded region, if I were to take this and start rotating it about the x-axis, you get this region, which this is like the 2-dimensional shape, and then this, yeah, again, you have to kind of use your imagination. This is the 3-dimensional with the shading. So how would we figure out the volume? Well, the volume's going to be, I always like to put the pi outside, so it's pi. The integral goes from -2 to 2, and it's 2 plus x cosine x, and the whole thing is squared. Now this is a calculator problem. I want you to just do math 9. And actually, if you have your calculators out, I put a program on. Oops. I didn't mean to do that. It's pi r squared. Remember, anytime you see, guys, anytime you see the word revolved or rotated, it's going to be pi f of x squared.
Why the radius?
Y is the f of x is the radius. Okay, so go to math 9. Pi r squared. Now I'll put my pi in later. So negative. What's wrong? Go to math. Hold on. It's okay. Do math 9. Do negative 2 to 2.
Is it okay to put the square?
And then I have, no, it has to be outside. So I started a new parentheses, so I put 2, oops, not 2. 2 plus x cosine x, close parentheses, another parentheses squared.
Oh my god.
I know. You probably didn't need the second one,
Well,
but,
I'm glad I'm not doing this right now.
and then times pi. We get about, what, 50?
78.2.
Is your calculator in radians?
Here's what I got 24.8. I got 25.13.
Does anyone want to check my test?
I wrote it down right?
I don't know. I just didn't.
What? I'm just gonna accept it.
What's the problem? Then you probably didn't put the squared on the outside of the parentheses. You have to close the parentheses. There should be 2 parentheses after the x. If you only have one, then it's just going to square the cosine part. You need to square the whole thing. Okay, I put a program on your calculators. Oops. You have a volume program. If I transferred programs onto your calculator, then you have this volume program. So I want you to try it. Go to. So press program, press volume, press enter. You'll just press enter again. Okay, it's going to bring you back to this screen. It's going to ask you to enter the curves. So press enter. Now, you have f of x or f of y. We want f of x, okay?
What do I do now? I got the answer.
Now, we're going to type in 2 plus x cosine x. Now, when we press x, t shows up. That's fine. It uses something called parametric equations, so don't worry about it. T is the variable. So we press enter. Curve 2. For right now, we don't have a curve on the bottom, so I'm just going to type 0. Press enter. Now, the x min and the x max, this is our viewing window. So I would just look at here. My x min is negative 3. No. Don't press anything while you're in the program other than just typing in. So negative 3 to 3, and then I'm going to do negative 4 to 4. This is just the viewing window.
Just like checking oriented, right?
Okay, after you're done, you just keep pressing enter. So this is going to graph the curve. Good?
Is this just checking our answers?
You'll see. Okay, well, I'll have to transfer it later. number 3, go with number 3, enter bounds. We're going to enter manually because what was the lower bound? It was -2. The upper bound was 2. It was -2 to 2. That's what it was given, right? -2 to 2. Okay, press enter. Okay, what it's going to do is it's going to duplicate. It's going to shade this region in. This ends up being the area under the curve.
Is it possible to do this in the ADV?
Yeah, I just have to put the program on. Okay, once it's done shading, press enter. That should be the area that we saw. Good. All right, axis of rotation. Well, it's a great way to check your answers. So number 4, axis of rotation. We're rotating it on the x-axis, right? So that's a horizontal. We get y equals 0. So now what's going to happen? Y equals 0. It's horizontal. It's going to duplicate it. It's going to create. Now, you can actually go back. I'm not going to bother drawing the rectangles, but just so you know, I feel like I'm teaching to like 3 people right now. Stop talking or leave. So, take a rectangle. You can actually draw a rectangle, and you can rotate it, okay, just to get an idea of what it looks like. My calculator gets an error. I don't know if something happened when I downloaded it on here. But those of you that I transferred the program to can do that. Otherwise, you could draw these rectangles, and it gives you like a 3-dimensional view. Yeah. But otherwise, just go to number 6. And it'll give you your answer right here. Okay, moving on. Here. Okay. You only have to worry about one radius. You only need to worry about one radius if it's right up against the axis that you're rotating about. But sometimes you end up with like a gap. Like imagine if you had 2 graphs. Like let's say I have a graph, here is f of x, and then here's g of x. And what if I wanted to rotate this? Do you see how there's like a gap in between the curves, the shaded region, and the x-axis?
What part of this is
We actually have we have an outer radius. So imagine if we're rotating this is the upper curve becomes the outside radius, and the inside curve becomes the inside radius.
So we actually have models.
So like this is big R, this is little r. So our formula becomes big R squared minus little r squared. It's exactly the same as what we just did, except that we have 2 functions to consider. So we have to the hardest part here is just basically figuring out which one's the outside one, which one's the inside, or the big R versus the little r. The big R is the one that's further away from the axis of rotation. See how big R is further away from the x-axis? This one's closer. So I'm going to take... We can. I don't have anything in particular, but... Okay, take this example. This is y equals cosine x. And this is y equals sine x. And I want to rotate it here. So there's a couple things I need to figure out. First of all, I need to figure out which one is big R, which one's little r. Okay, so big R is cosine x, little r is the sine x. The other thing I need to figure out is the bounds. Well, it starts here at 0, but I need to figure out what is that x coordinate. How do I find that out? How do we figure that out?
Set them equal to each other.
Okay, when are sine and cosine equal to each other on the unit circle? Okay, so if you did not know this, you could graph this on your calculator. Look at where they intersect and just write pi over 4 to 3 decimal places. That's fine. Okay. You good with that? Okay, so what's my integrand look like? It's big R squared minus little r squared. So it's going to be, okay, so cosine of x squared minus, again, this is just, by the way, if you use the volume program and you want to stop using it, just make sure you press 7 to quit. Otherwise your mode and everything gets mixed up. So we want to do math 9. So from 0 to pi over 4. So I have cosine of x squared minus sine x squared. Oh, and that gets multiplied by pi. So it's basically 1/2 pi. So as long as you put the square here, it's going to do sine squared. Questions there?
So for this, would I be moving 4 over 4 over
Plus, oh no, evaluated.
What is that? I don't know what that means.
Well, you have bounds. Evaluated from 1 to.
Oh,
Oh,
I
did you
just-
change the bounds?
Yeah.
Okay. So use those new bounds.
But I can do it like from this. Like I can use that equation, or do I have to integrate it again?
Oh.
How many points did I get off of my just answer any of these questions?
Okay. So we're going to take this region bounded by the square root of x. So this is the square root of x, and this one's y equals 1/2 x, the lower curve. So we want to take this shaded region, and we want to rotate this about the x-axis. Again, we need to figure out where do they intersect. So we have pi. What are the bounds? 0 to, where do they intersect? How do we know that? Okay, so you could actually set it up or you could solve. Did we get that? So at 4, what's big R? Square root of x. So square root of x squared, what's little r? 1/2 r. Or 1/2 x, excuse me. Again, on the quiz, I'm just going to say, write but do not evaluate the integral that represents the volume. And then for part B, you get to just plug it all into your calculator. So there's not much integrating by hand. It's more, do you know how to set up the problem? Okay, that volume program that I just showed you would be a great way to see if you set it up correctly. So, what's that? Oh, yeah, I didn't finish it, but how would you solve this equation? Yeah, or I could do x equals 1/4 x squared. Well, you should actually subtract, but. And then factor out an x, so we have 1/4 x minus 1. So when x equals 0 and x equals 4. Is that what you guys got? So math 9. So square root of x squared will just be x, minus 0.25 x squared. dx. So 2.6, so 2 2/3 or 8/3 repeating, 8 pi over 3. Yeah, that's why, yeah, 8 pi over 3. Or multiply it out and change it into a decimal. So decimals are going to be completely fine for this class. It's fine if you write everything. Now, I will kind of give you a heads up. In terms of the y-axis, I made this a bonus problem coming up. So I'm just going to have you guys worry about rotating about the x-axis, but I do want to show you, what do you think happens if you rotate it this way? So imagine, what's this kind of look like? It kind of looks like a cone, but it's kind of scooped out, curved inward. Can you picture that? So this was y equals square root of x, and this one was y equals 1/2 x. But when I rotate with respect to the y-axis, I want to change everything to y. In other words, this was the point, so this was 0, 0, and this was 4, 2. So when I do my volume, instead of going from 0 to 4, I want to go from 0 to 2. Okay, I'm using all y. Now, I have to figure out which one is big R and which one's little r. Which one's the outer radius if I rotate it this way about the y-axis? Is it the square root or is it the line? Yeah. Which one is bounded on the right? Which one, also you can think of, which one is further from the y-axis? The 1/2 x. So this is my little r. Or, sorry, big R. I meant big R. And this one is little r. This one's further away from the y-axis. This one's closer. Big R is always bigger, further away. But I don't want to put in square root of x, and I don't want to put in 1/2 x. Remember, what do I want to do? I want to change everything so that it's in terms of y, not in terms of x. So take, right, take each one, take y equals square root of x, and take 1/2 x, and solve for x. Does that make sense? So what happens when I solve for x here? I get y squared is equal to x, and what happens here? I multiply both sides by, so I get 2y. So again, 2y is my big R, y squared is little r. So I have, it's going to be 2y squared minus y squared squared. Oops, and at the end goes dy. Yeah, so when you actually plug this into your calculator doesn't care what variable you use, as long as it's consistent. Could I actually plug in y? Yes. I honestly would not bother. I'd just use it the way our variables show up, which is with the x. So 2y squared, if you want to put it in, is what? 4y squared? I'm going to do that part. And then minus, what's the next part become? Y to the 4th. And then, just again, whatever variable you use here, you have to use it. What happens when you plug it in? Okay, and then I'll just change this to a decimal. So I'm going to multiply by pi. You could honestly put the pi in first and then do math 9. I always do it like this for whatever reason. 13.404. Yeah. If you use the calculator program, so if you set it up